Welcome to this course on quick changeover using the powerful reduce methodology. As you may or may not know already, Lean Strategies International LLC's vision is to educate, empower, and transform organizations and lives around the world through the power of continuous improvement strategies. To do this, we work to provide affordable and comprehensive coaching, educational opportunities, and supplies that can be measured through the success and experience of our partners and you, our students. The method we will learn about in this course is based on the SMED system. This powerful system will make your workplace and you more productive and efficient. In addition, changeovers and the work you do will become much easier. The reduce methodology breaks down the single-minute exchange of die system and simplifies in detail how you can reduce your setups and changeovers to below 10-minute time. This course will give you a comprehensive understanding of each of the steps in the methodology and will challenge you to go and use them. Through the course, you will learn about changeovers, operations, setups, and a process that will allow operators and office personnel to apply and improve. Like many courses with Lean Strategies International LLC, you will learn in comprehensive lectures, study handouts, test your knowledge with quizzes, and complete activities all through the course. You'll have access anytime you want, so you can log in and work at your own pace. Rest assured, by the end of this course, you will have a much deeper understanding of changeovers and how you can streamline and improve the setup process. So, look through the various descriptions, watch the free previews, and then enroll in the Quick Changeover course with Lean Strategies International LLC, and let's get started creating solutions that ignite your power today. Welcome to your quick changeover journey. Whether you are a seasoned professional or just getting started on your journey towards excellence, this course will enhance your skill set. Before we get started, let me first share a little about Lean Strategies International LLC. It is our vision to educate, empower, and transform lives around the world through the use of continuous improvement strategies. We do this by providing affordable and comprehensive educational opportunities and coaching that adds value for you. This course will be a great first step for you in developing the skills you are seeking to enhance your life and the organizations you work for. You may be wondering, what is this course based on? Quick Changeover with Reduce is based on the SMED system. SMED stands for Single Minute Exchange of Die. The concept is that all changeovers and setups are reduced to 9 minutes or less. A single minute. Shigeo Shingo developed the SMED system over 20 years of his esteemed career and documented the system in his book, A Revolution in Manufacturing, the SMED system. Over the course of Dr. Shingo's career, he identified two main categories for setup operations: internal setup activities and external setup activities. He learned and later taught that many internal operations could actually be done externally. This dramatically improved changeover and setup times while allowing companies to run machines and create value for longer periods of time. The reduce methodology presents the main concepts of Dr. Shingo's SMED system in a more granular and simplified approach. For even more details, we highly recommend reading Dr. Shingo's book yourself. With that being said, The lectures, quizzes, and activities will give you a comprehensive understanding of what Reduce and SMED is, why you should implement the Reduce methodology, what the benefits of the Reduce methodology are, what the critical elements of operations and setups are, the 4 basic steps of a setup, an overview of the Reduce methodology, and the 6 steps of the Reduce methodology. Now that you have a basic understanding of what you are about to learn, let's get started with the course. Remember that throughout the course, downloads will be available for you in the resource section, so be sure you have access and download all templates and handouts. Also, you can access the materials anytime, so be sure to take your time and go at a pace that suits you. Okay, let's get started with the first module. Welcome to this first introductory module. In today's day and age, customers don't want to differentiate volume and variety. They want both. In addition to more volume and high variety, customers still expect perfect quality, the best price, and better than on-time delivery. If that makes you cringe, don't. SMED using the Reduce methodology can help organizations better meet those needs as well as help employees meet those organizational skills. Essentially, the system provides a way for companies to reduce waste and still make it profitable to produce in smaller lot sizes. With that in mind, this module will look to answer 2 main questions. What is SMED? And what is the Reduce methodology? Single-minute exchange of die is a concept developed by Shigeo Shingo. SMED seeks to perform all setup and changeover times in under 10 minutes. In other words, it seeks to complete all changeovers in 9 minutes or less. There are 3 main steps in the SMED system. Separate internal and external setup, convert internal setup to external setup, and streamline all aspects of setup operations. You will learn more about these steps later on in the course. The Reduce methodology is a more detailed method of performing quick changeover or SMED improvements. The steps in the Reduce methodology are required data, engage with value stream, differentiate internal and external steps, undergo conversion, clean up the process, and finally, ensure the steps work. As you can see, both the SMED and Reduce methodology have a very structured approach to them. In this course, we will focus on the more detailed Reduce methodology. However, we will revisit various aspects of SMED throughout the course. Let's move on to the next module. 20 years ago, when Dr. Shingo first began developing the SMED system, nobody would have thought this system could reduce a setup time from 4 hours to just 3 minutes. And then he did. This was a revolutionary improvement at the time and would later become a critical aspect of any lean organization. While this story is quite powerful, the Reduce methodology, which is based on the SMED system, presents the details that are needed to improve every changeover and setup. It is noted that not all setups and changeovers are capable of being complete in 9 minutes or less. Nonetheless, every setup and changeover can be improved through the implementation of the Reduce methodology. With this legendary story in mind, you may wonder what exactly are the benefits of Reduce. The reduce methodology empowers organizations to do much more than they think. The general assumption that setups take a long time and large batch sizes need to occur to absorb the setup becomes much less of a risk when changeover time is reduced. It goes without saying that if a setup can be done quickly, an organization could change over as often as they need. This gives organizations more flexibility to meet the always evolving needs of their customers. Faster changeovers also mean faster delivery. When you can produce to demand in smaller lot sizes, your lead time significantly improves while your wait time is significantly reduced. The reduce methodology also improves quality. Because you are only producing to demand, inventory will naturally decrease. You no longer keep stockpiles from long runs. As inventory decreases, storage-related defects such as expired product, damage, and even pilferage will go down. In addition to this, improving on errors that occur in the setup process drastically reduces the amount of defects and trial runs that occur. In fact, if a defect were to occur in an improved changeover, it would be easier to spot because the lot sizes are much smaller than in a traditional setup. Shorter changeovers also mean less downtime. Less downtime means more uptime and more value created. Another benefit of quick changeover with reduce is that the methodology helps lower inventory costs. The more flexible you are, the more you can build to demand only. Building to demand or pulling based on customer requests ensures that you have what is being sold. This also means that storage space is reduced and work areas are cleaner and safer. While these are only a few of the benefits of implementing the reduce methodology, one stands out, and that is that plain and simple, the quick changeover with reduce methodology will benefit your organization and the people who work in it. Before we start discussing the details of the reduce methodology, we first need to dig in and understand a few terms that you have been exposed to already. These terms will help you understand the different aspects of your quick changeover and hone in on opportunities much quicker. Let's begin by defining the term changeover. A changeover is the work required to change a specific machine, resource, work center, or line from making the last good piece of an item to making the very first good piece of the next item. So, if the first piece after the changeover is not good, the changeover is not complete. Let's look at an example. Here we see a Formula One car performing a changeover or pit stop. The car pulls up and immediately the team gets to work on refueling, cleaning, and changing the tires. This downtime is the changeover. Let's imagine for a second the wheels are part A. They are running fine. The Indy car stops and begins moving and removing on our part A. They then begin to install part B, which is the second set of wheels. That time in between the car pulling in and stopping is the changeover. Another term that is used to describe the work required to change a specific machine, resource, work center, or line from making the last good piece of an item to making the first good piece of another item is setup. This includes the preparation and adjustments that are performed until the first good piece is processed. An example of this could be when one patient is complete in surgery and the surgical team begins preparing for the next surgery. This time in between is the setup time or changeover time. You may also hear this time referred to as turnaround time. As you now know, changeover, setup, and turnarounds all refer to the work required to change a specific machine, resource, work center, or line from making the last good piece of an item to making the first good piece of another item. For simplicity, we will refer to all three of these terms throughout the course. There is one more important element to every changeover. As introduced earlier, Dr. Shingo identified two activities that occur in every changeover. Those activities are known as internal activities and external activities. We cannot reduce or improve any changeover without understanding these activities. Internal activities refer to the activities associated with elements of a changeover or setup procedure that can only be performed while a process or machine is not running. Let's look at our Indy example once more to understand this concept. As we can see, the tires can only be changed when the vehicle is stopped. We should note that even though internal activities can only be performed when the line is stopped, these activities generally have significant opportunities for reduction in waste. External activities, on the other hand, are the activities associated with the elements or activities of a changeover procedure that are performed while the machine is running. These activities are done outside of or away from the machine or external to the process. When looking at the drastic improvement in the time between the 1950 pit stops changeover and the 2013 Melbourne changeover, we can see that wheels are brought to position in advance, team members are crouched down to remove excess motion, tools are in position prior to the car arriving, and any other supplies are ready to be installed before the Indy car even arrives. These activities were prepared and performed all while the car was still racing. We will dig into this amazing changeover reduction more throughout the course. Now that we understand these concepts, let's move on to the next lecture. Before improving anything, we must first consider the current state or common problem areas of what we are improving. In the case of setups, changeovers, or turnarounds, there are traditionally 4 basic steps or areas where problems and opportunities fall. Those steps are preparation, removing and mounting, tools and parts, measurements, calibration and settings, and finally, first articles, trial runs, and adjustments. The preparation phase of a traditional setup is one of the largest portions of a setup or changeover. On average, you will find that anywhere between 25% to 30% of your opportunities will occur in the preparation phase of a traditional setup. The preparation step ensures that any necessary parts, tools, and materials are located where they should be and are working and in proper condition. This phase also includes any after processing that needs to occur, such as removing items and putting them in the proper storage location, cleaning machines or lines, and returning any other items. Traditionally, this occurs when a line, operation, machine, or process is stopped. However, as you can tell by the description, many of the steps that would occur here are in fact external activities and can be done before the equipment is stopped or after when the machine begins running again. One thing to note is that whether you are preparing for your changeover, making adjustments after a process, or checking for materials and tools, this preparation phase can oftentimes be reduced from 30% of your setup time to 0%. In the second phase of traditional setup, the actual changeover occurs. This is when the removal of any parts or tools from the first batch or lot occurs and the mounting and attaching of the second lot takes place. In general, this step can only be performed when the machine is stopped, which means it is mostly based on internal activities. This does not mean that improvements cannot take place, but generally they have more to do with training, tooling, and standardization of activities. In comparison to the other phases of a traditional setup, this phase only consumes about 5% to 10% of the setup process, which, as you now know, is not very substantial in comparison to other parts of a traditional setup. Despite this obvious fact, we should remember that all improvements, even the smallest ones, are a step in the right direction. So, don't ignore this phase by any means. Squeeze any and all waste you can out of it. The third phase of a traditional setup is about 15 to 20% of the traditional setup process. This phase includes measuring, calibration, and establishing correct settings. It includes any and all measurements that need to be made to ensure that the production run, item, line, or service is done correctly. This may include, but is not limited to, measuring pressure, temperature, dimensions, and any other dimension that would need to be calibrated or checked. If we look at this example of a pit stop on an Indy car, the torquing of tires, air pressure, gas refill, and calibration of any other parts of the car would fall into this phase. Something to keep in mind is that many of the steps which fall into this portion of a traditional setup are considered to be internal activities. However, improvements still can be made. With that being said, the measurements, calibration, and settings phase should still be optimized. You will learn how in later modules of the Reduce course. The final phase of a traditional setup is the one that traditionally takes the most time. In phase 4, adjustments and trial runs are performed to dial in everything from measurements, calibration, and the settings phase. In general, this step involves machining a first article, test piece, or trial part. Then it is inspected and adjustments are made. This is oftentimes a back and forth process until the output is correct. These adjustments can be simplified by having more accurate measurements, calibration, and settings in the previous step. This is easier said than done in many cases. However, through the use of the reduce methodology, this phase can oftentimes be reduced from 50% of your traditional setup to 0%. Looking back on our definition of changeover, we are reminded that the changeover is not truly complete until the first good piece is produced. With that in mind, the traditional setup cannot truly be complete until this step is finished. This makes this phase another internal setup. We will learn how this step can be eliminated so that acceptable outputs can be produced right away. With this understanding of a traditional changeover or setup, we are now ready to begin learning about what we can do to begin to reduce our setup time. We'll see you in the next module. Now that we have a good understanding of changeovers, the traditional steps, and the two main activities that take place in a changeover, let's dive into reducing changeover times. As was mentioned earlier in the course, the reduce methodology is a more detailed method of performing quick changeover or setup improvements. Reduce is based on the SMED system, which was created by Shigeo Shingo. The methodology encompasses 6 steps that support the 3 overarching stages of a setup reduction. With that being said, one of the
Hmm.
contributing factors of a long
Hmm.
setup time is the confusion
Hmm.
associated with internal and external setup times.
Hmm.
This often results in many changeover tasks that could be completed while the machine is running, not being performed until the machine is stopped. As such,
Hmm.
setup times are much longer. So, how do we reduce setup and changeover times? Let's look at a high level of each of the stages of the reduce methodology. Phase 1 is the required data. Once you have identified the area that your changeover or setup reduction will take place in, you will need to decide what data to collect. At the heart of a setup reduction is your setup time. You can gather this by starting a stopwatch at the beginning of your setup and stopping it when the first good piece is produced. Some other suggestions for data you might want to collect are yield, cycle times, and of course, any types of variation in the changeover. The second step is called Engage with Value Stream Mapping. Now that you have decided what data you will collect and the team is focused on objectives, it's time to lay out how the changeover actually occurs in the current state. This is where you will want to collect the data you decided on in phase 1. 3 very effective methods that help reveal the current state are walking the Gemba, mapping the value stream, and videotaping it. Videotaping can allow you to slow down or speed up the process in order to see everything that is going on. What we hope to gather here is a complete understanding of the process in its current state. If inspiration hits for improvements, place them in a parking lot until the time is right and all elements of the changeover have been taken into consideration. After this, we differentiate internal and external steps. This is one of the most important steps in the reduce methodology. When you differentiate and distinguish steps that are internal and external, it becomes clear that activities like preparation and transportation of items are better done while the machine is running. This portion of the reduce methodology could result in as much as 50% reduction in your setup. After differentiating steps, we move on to undergo conversion. Now we are ready to convert internal and external setup steps. The objective here is to change as many internal elements to external steps. Some common improvements for conversion are preparing parts, tools, or information in advance of your changeover. You may also want to look for opportunities to use clamps in place of screws and bolts, or minimizing the need for test runs and any adjustments associated with the activity. This generally involves 3 key activities: moving forward with your initial conversion, re-examining your operations and converting any other steps that may have been wrongly assumed as an internal setup activity, and discovering ways to convert internal activities to external activities. After conversion of internal and external steps, we want to clean up the overall value stream, removing any types of waste remaining in the process. Some of the more common ways to clean up the process are by reducing the need for transportation, motion, and waiting. Oftentimes, operations can run in parallel with one another to streamline the process. As a last resort, teams sometimes look to mechanize, automate, or invest in robotic activities. These types of improvements require significant capital expenditures, which is why we want to be sure we do everything we can possibly do before looking to investments that may yield only a small cost to benefit for the outcome. As a final activity, it is important to ensure that the steps work and are in balance. We don't want to place any unnecessary strain on workers or create a process that only works for a short time. This would only result in poor yield and variation in the process. These 6 steps are only an introduction to the reduce methodology. In the next few modules, we will look at each of these steps in greater detail. In the first phase of the reduce methodology, your focus is on deciding what data to collect. This data should help you prove your improvements and continue to improve the process as time goes on. It is suggested that along with data, you decide what types of notes you want to collect while visiting the Gemba. For example, if we are trying to reduce the setup or changeover times, we would want to grab a stopwatch and prepare to collect the amount of time it takes to change over from the last good piece to the next good piece. This data would be documented. A simple sample template is shown here and available in the resource section of this module. While at the Gemba, document the sequence of events, times if you can, and whether the step you see is internal or external. You can use the notes column to add any other details such as waste seen, imbalances, and possible improvements. Some other forms of data you may want to consider are cycle times, current lot size, yield, and maybe even the total lead time. In addition to data, you should collect notes as well. Some notes may include forms of waste you observe in each step of the process. A good way to ensure you collect the right data and notes is to walk the value stream forwards and backwards as you decide on what forms of information will help you accomplish your goal. This is referred to as a Gemba walk. While walking the Gemba and reviewing your improvement opportunity, look for some of the following setup and changeover characteristics. The changeover is long enough to have opportunities to improve, but not so long that it is overwhelming. It has variation in the timing or output. You can also look for a changeover that has frontline workers who regularly see or are part of the setup or changeover. This will be critical in your resources in reducing your times. These people can be talked to and provide valuable information. Other opportunities are changeovers that take excessive amounts of time, which may be anywhere from a half an hour to an entire day. After you have completed your study of the process, you should go and speak with the people who are performing the setup and the operation. They may be able to tell you in advance if you have any data or information already there at the Gemba. The most common form of data used in the reduce methodology is setup and cycle times. One last thing before we move on. As you decide on required data, be sure that you are seeing the process as is, not as it should be. This will help you understand things as they are and help you see improvements as they could be. Once you have determined what the required data is that you will need, you're ready to engage the value stream. If you have ever designed a process, let alone a changeover, you know that it is absolutely impossible to get everything perfect right from the start. Because of this, we must constantly be analyzing our setup operations. Amongst the most common reasons that traditional setup operations take so long are steps are sequentially incorrect and excessive waste in the process. Internal and external activities are confused functionally. This causes tasks that could be done while the machine is still running to wait for the machine to stop before they can be done. With this in mind, we need to first look at what is happening in the current state or the as-is condition. There are three different techniques that are used to analyze or engage the value stream. The first is a Gemba walk. A Gemba walk is the term used to describe a walk where employees go to observe work at the Gemba, which is where the work is done. The idea is to go and see for yourself at the actual or real place of work. On your Gemba walk, you document notes and gather information to deepen your understanding of what is going on. You completed a simplified version of this with your template in the required data stage. The second technique, and possibly the most effective, is to record a video. In today's day and age, video is one of the most effective ways to capture the entire setup. This could be done on an iPhone, Android, or any other device that can capture video. Try to use a device that can capture high quality, clear video, as well as the date and time of the video. The video will give you a play-by-play that you can speed up, slow down, stop and zoom in and out of if you would like to. You'll want to capture video that really focuses on forms of waste like hand and body movements, transportation waste, motion waste, and overprocessing. The video can be shown to the person or the team that completed the actual setup. Then they can help you to find opportunities. The last technique is to map the value stream. Value stream mapping is another very functional way to capture the different elements of the setup. We suggest that while one person is recording, another is laying out a series of post-it notes that documents the different elements of the setup near the area where the setup operation is performed. This can be done on a table, wall, or even at the machine. Since most setup operations are performed at an operational level, you may want to consider using the Treat 1, 2, 3 method. This will make mapping the elements much easier. A good way to map this is with the process elements on one level. Below your setup elements, you can place the data you captured for the element above. You should use some type of stopwatch or other measuring device if need be to ensure your data is correct. Then, any types of inputs and outputs such as tooling, materials, or information, and finally, one row dedicated to problems you see at that level. At the very least, be sure to capture the top level or setup elements. This value stream can be adjusted for more accuracy when you watch a recording if you need to. Once you have documented your value stream, you now have a significant amount of data and information that you can use to drive your setup reduction. One tip is to keep the value stream in the area. As you adjust it into a future state map, you can continue to analyze right at the Gemba. With required data ready and our now deep understanding of the value stream, we are ready to move on to the next step where we will differentiate internal and external setup activities. See you in the next module. Of all the steps in a setup or changeover reduction, separating internal and external activities may in fact be the most important as well as the simplest steps you can take. In the most general sense, performing activities like preparing tools, kits, and materials, as well as transporting items while your line is running, can reduce setup time by as much as 50%. As a reminder, internal tasks are those tasks that can only be performed while the machine is stopped. External tasks, on the other hand, can be performed while a machine is running. When we look to differentiate between the two, we are trying to separate work elements or tasks into a group of internal and external tasks. There are many different tasks that can be performed before a machine is stopped. Let's take a look at our IndyCar for a few common examples. Some of the more obvious ones that occur here are lining people up and positioning them at a level that reduces motion, preparing wheels or other parts before the car is stopped, organizing and preparing tools before the car is stopped, situating equipment, tools, and parts as close as possible to reduce excessive forms of waste, and using proper equipment. While these obvious examples may seem quite simple and logical, the reality of an everyday setup is that it may not occur this way. Review your Gemba notes, watch your video, and take another look at your value stream. You will more than likely find that many of the external activities are being performed after the machine has been stopped. If so, you may have an opportunity to reduce 50% of your setup time right away. How do we do this? As implied earlier, we need to separate the activities into our setup into internal and external activities. There are 3 commonly used methods to do this: use of checklists, performing regular function checks, and reducing transportation waste, specifically with tooling and parts required. Let's take a look at each of these in our upcoming sections so that we can understand how these tools will help you separate internal and external activities. Got it. Got it? Yep. Oh, I forgot that one. In this lecture, we will look at one tool that you can use to ensure you have everything you need to reduce your setup or changeover time. A checklist is a tool that can be used to ensure that you have everything required to set up and run your next operation. There is no standard format for a checklist as long as it works appropriately and can be standardized. The following are common items that you can use to outline or develop a checklist. Just be sure that you adapt your list to your needs. Parts needed, tools needed, specifications, and workers. You will also want a section to list appropriate conditions for work, such as temperature, pressure, power, skill set, and any other necessary conditions. Another suggestion is to have a section for correct calibration, measurements, and dimensions at each operation. As a reminder, checklists will be unique to your specific needs, so be sure to customize and benchmark other best practices. One suggestion is to Google checklist examples and take a look at a few different options. This type of benchmarking may spark some great ideas. Be sure to cite your references. Let's look at an example of a checklist. Please note that this template is available if you would like to try it out. If you do use a sample checklist, be aware that each machine and operation checklist should be made specific to that machine and operation's needs. Checklists that are generalized can cause confusion and result in slower times if not used properly. Also, keep in mind that this is a pre-changeover checklist, which means items and activities on the checklist should be performed externally before a machine is stopped. In this example, we see examples of each of the suggested categories and an added one that documents who the checklist was completed by. To use the list, an employee would simply go through and gather each of the categories and confirm them with a check mark. As you can see, this checklist also has a notes column to add additional information if needed. As you can see, a checklist is one of the easiest ways to ensure you have every item needed for your changeover in a simple list of everything. Checklists can be implemented with software or a pencil and paper. The only thing you need to make sure is that you check using a checklist off of your list of things to do. Much like a checklist will help confirm if you have the appropriate items, machines, and parts, and that they are in the proper working order, a function check or functional test will help you measure the ability of your equipment to perform and work as it should. It is suggested that a function check is done before and after a run when you first start conducting the function check. This will ensure that the items you need to work are working properly. Once you have your function checks occurring on a schedule, many organizations will perform the check immediately after a run. This way, if tooling, materials, or information needs to be corrected, it can be done well in advance of the next run and stored safely so that it is in working order for the next time it needs to be used. If it is not practical for you to advance to a functional test immediately after the setup is broken down, then ensure they are done well in advance of your changeover so as to minimize any downtime. Function checks are oftentimes developed using checklists, process flow diagrams, or decision maps. These tools help standardize the function check and will allow you to develop a process that could drastically improve your setup or changeover times. Gauges, tools, dies, molds, clamps, parts, materials, and other items needed for a setup operation are moved to and from a work area when a changeover occurs. This can cause excessive amounts of transportation, motion, and other forms of waste if tooling is not placed in an easily accessible location that is in 5S condition. If this is performed during the internal setup time or the time when the machine is stopped, downtime will be much longer. With this in mind, any and all items needed for a changeover should be placed in a location that is easily accessible for the person performing the setup operation. If placing items in an easily accessible location is not a possibility, then items should be transported to the machine before the machine is shut down, and from the machine after the line is back up and running, or by another resource. The purpose of this is to get the machine up and running as quickly as possible and reduce downtime. These three techniques will help you begin separating internal and external activities. Please note that this may require coordinating, lining up, or deeper analysis. But rest assured, as you identify and separate internal and external activities, you will see that your downtime will be reduced and your value adding time will increase. External or internal. As you've learned, external activities can be performed while the machine is still running. At the heart of external improvements is separating them from internal activities and ensuring they are completed before the machine is stopped or after the machine is up and running again. So, what can we do to improve activities that must be performed only when the machine is stopped? Internal setup tasks are business necessary. They add no value but are indeed necessary. Because of this, we must focus on reducing these internal activities. There are two steps. Understand the function and purpose of every task in your internal setup and innovate unique ways to convert internal steps to external steps. Understanding the function and purpose of every internal task involves looking at activities as they occur, not as they should occur. Remember, you have taken a Gemba walk, gathered information, recorded the setup, and mapped the process out. This valuable information will allow you to look at the setup process in the current state. As you do this, you will likely find that these common techniques will help improve your internal setup. Prepare operating conditions in advance. Standardize essential functions and use of intermediary jigs. Preparing your working conditions in advance of the actual internal activity can drastically shorten your changeover time. As part of the undergo conversion phase of reduce, this step looks to ensure that these activities are performed externally and not during the internal phase of your changeover. Some examples may be heating up or cooling down temperatures prior to the internal activity, establishing the correct pressure, time, or settings before the internal activity occurs, and positioning materials, tools, and equipment before they are needed for the internal activity. All of these activities can be done while a line is still running. Another powerful technique that can be effectively used to reduce the time spent on internal activities is the standardization of essential functions. As a setup or changeover begins, tools and supplies will be needed. When tooling is disassembled and attached, the tools required are oftentimes different. This is an essential function that must be performed, but it is also business necessary because it is not transforming the materials or information that the customer is paying for. It is not uncommon when operators are disassembling and attaching tooling for them to run back and forth to find the correct tools and make adjustments. This eats up time and does not always produce the desired output. To combat this problem, the reduce methodology borrows from the SMED system with an approach called function standardization. Function standardization requires only uniformity in the parts and features necessary for setup operations. The functions identified by Dr. Shingo in his book, A Revolution in Manufacturing, the SMED system are clamping, centering, dimensioning, expelling, grasping, and maintaining loads. There are two steps in the implementation of function standardization process. Decide which steps in your setup process can be standardized. Then, after standardization, decide which functions can be made more efficient by replacing the fewest possible parts or eliminating them altogether. The fewer the replacements needed in internal activities, the better. 0 replacements would be ideal. Another way that internal activities can be reduced is through the use of intermediary jigs. A jig is a type of custom-made tool used to control the location and/or motion of a part or parts or other tools in a setup. In this case, a custom jig can be made or purchased to quickly attach tooling. Oftentimes, if the jig is standardized, it can be left on machines so that tooling can be attached even quicker. These are some proven techniques that can be used to undergo your conversion. Remember, you have been to the Gemba, and your observation form should have established whether the activities were internal or external in the current state. As you understand what each of those functions truly needs to do, you and your team will likely find ways that are unique to your conversion process. That is okay. Now that you have a good start on converting activities, let's move forward and prepare to clean up your process. Since much of the focus of the reduce methodology and SMED is focused on internal and external activities, cleaning up the process can be broken down into two areas: improve or eliminate the remaining external activities and improving internal activities. Because much of this section borrows from the practical approaches shared by Dr. Shingo in his book, A Revolution in Manufacturing, the SMED system, we will break them down into different lectures for your understanding. Let's get started. One of the first things you can do to clean up or streamline your changeovers is to clean up external processes that you may not always consider. For example, retrieving a tool is a natural part of the process, but does not add value and consequently waste time. When improving or eliminating the remaining external activities in your external setup, one of the largest opportunities you will find is in the transportation and storage of tooling, materials, parts, and information. Looking around for hours to find the right equipment will not add value for anyone. One effective system that can be used to improve the external transportation and storage of materials is the 5S system. The 5S system is a visual workplace management system that promotes safety, efficiency, and teamwork while making abnormalities visible. As you use the 5S system to streamline the storage of materials, tools, and equipment, keep these three questions in mind. What is the best place to put these items for easy access? How can these items be stored so that they are ready for the next use? Do we need to keep inventory on hand? If so, how much? As you consider these questions, you may also wish to map the flow of items with a spaghetti diagram or flow chart, review distances, and ensure that items are at ergonomic levels and with safety in mind. Keep in mind that various improvement tools can be used to reduce or eliminate remaining waste in your external process. As you establish better storage and retrieval practices, you will find that external activities can be reduced to 9 minutes or less. After every possible form of waste has been squeezed out of the external activities, improvement of the internal activities can take place. This can be a bit more tricky than improving external setup activities and oftentimes requires engineering assistance, investments, and a little bit of planning. Nonetheless, there are some things that you can do which will bring your times into the single-digit time frame. The four techniques that can further reduce your setup or changeover times are: first, converting sequential steps to parallel steps where possible. Second, use of clamps that are functional. Third, eliminating any and all adjustments, and last but not least, mechanization. As with any other portion of a changeover, there are some powerful methods that Dr. Shingo shares more about in his book, A Revolution in Manufacturing, the SMED System. We will look into each of these techniques as we drive time out of and improve our internal setup activities. See you in the next lecture. One of the first things we can do to further clean up our internal setup activities is to analyze and implement parallel operations. The word sequential is defined in one way as following. In the case of your setup, steps are often performed sequentially or in a sequence, one following another. When this occurs, it requires us to wait until the previous step is complete before moving on to the next step. Looking at our Indy example again, we see this sequential activity as the pit team works on the front right tire, first banging profusely to remove the tire, then walking to pick the tire up, and finally placing the tire back on while again banging to tighten the tire. Parallel operations, on the other hand, can do activities in parallel or at the same time as others. For example, in the 2013 Melbourne pit stop, we see a pit team member run up with a tire in hand. We also see an individual at a specific marking point ready to work on the tire. To his right, another individual. As the wheelman gets the tire off, the individual to the right takes the tire and the individual to the left places the new tire on, while the wheelman prepares to tighten the tire. As you can see, parallel operations divide the setup tasks between more than one person, and oftentimes activities that are parallel processed are performed in unison with one another. This can help reduce an internal setup to below the 1 minute mark. One very important tool that is used when operations are converted from sequential to parallel is a procedural chart or a process chart. A procedural chart can be a simple template that allows you to document the sequence of tasks that need to occur at a very granular level. It also tracks the time of each step in the setup, the cumulative time at each phase, and should show whether the activity was internal or external. In the template, there is also a notes column where you can jot down your observations. To the right of the notes are many small boxes. These boxes represent the time of each step and whether the activity is internal or external. Each of these steps also show whether an activity can be performed in parallel or must be performed sequentially. The template is available in the resource section of the course for download. Using a procedural chart not only gives you a living document to see the setup and make improvements, but it also helps train employees and keep the changeover safe and consistent. When combined with visuals such as lights and other sensory devices like sounds, this can trigger the completion of one step and the beginning of another. As you see an opportunity to improve, you should update and standardize the chart. This will give you a living document that people can look to and discover more improvements as revelation occurs. Keep in mind that this concept of parallel processing can occur in many portions of your process. So, be sure to look for opportunities where you can make the most of the resources you have. Now let's move on to some more powerful internal setup improvements. It may seem like nuts and bolts are needed to complete your internal setup activities. In this lecture, we will dig into a few of Shigeo Shingo's legendary tips from the book A Revolution in Manufacturing, the SMED system. Nuts and bolts are cheap. You can get them everywhere. They hold items on and do the trick. With a few exceptions, of course. They take time to install, they get lost, they are mismatched, they can get stuck, and every turn except the last one is waste. As we learned earlier in the course, the purpose of a nut, bolt, or any attaching device is to secure and unfasten. This means that if a bolt has 10 threads on it, 9 of the turns it takes to securely fasten the bolt are waste, and only the first or the last is actually needed. The reduce methodology borrows from SMED with functional clamping systems and devices, instead of nuts and bolts. These devices not only save wasted time and energy, but they also can be custom made and attached to machines or information flow so that tooling, materials, and information do not get lost. There are 3 main functional clamping systems that we will introduce in this lecture: one-turn methods, single motion methods, and interlocking methods. One-turn methods, as the name implies, seek to eliminate the over-processing that is inherent in many nuts and bolts and screws by creating a one-turn item. This is the single motion items. These items require one motion to secure an item, such as a switch that is flipped or a button that is pushed. The final functional clamping method is the interlocking devices. These items generally slide into place to secure items. As you can tell, these 3 options are great alternatives to the long process of finding nuts and bolts, acquiring tools, and laboriously securing them during internal activities. You can find more details about these functional clamping devices and methods in the handouts of your course materials. See you in the next lecture. As was already mentioned, trial runs and adjustments can account for about 50% of your traditional setup time. As such, eliminating this time will yield a great deal of savings on your setups. To eliminate these tasks, you will need to look to the earlier phases of your setup and adjust and standardize how these activities are performed. There are 3 practical techniques shared in the book A Revolution in Manufacturing, the SMED system, that are used to eliminate adjustments: use of numerical scales and standardization of settings, making visual center lines and reference planes or points, and use of the least common multiple system. Intuition and experience can be a great blessing in a lot of different situations. However, in most situations, neither intuition nor experience will work identically every single time. Numerical values will create consistency. If you know that the oven should be set at 350 degrees to cook your favorite meal, the setup will be the same every single time you change over the oven. Whether it is distance, temperature, pressure, or torque, you need to standardize your numerical settings. To start, be sure that the settings are visible. This is often referred to as a graduated scale. Without this, you're only guessing. Many machines or software applications, in the case of information systems, do not have visible reference planes, points, or center lines. This makes it difficult to repeat applications or production without many different adjustments and a trial and error approach. Without a visible reference to the exact position of your needs, you are again basing your placement on intuition. By making these references and lines visible, it makes the setup much quicker and easier to perform. If a template can be made, this may be another option. Remember, we don't want to get closer to the mark, we want to eliminate adjustments. You may want to consider the following question. In my setup or changeover, how can I make center lines and reference points visible so that I no longer need to make adjustments? As you make centering lines and reference points visible in your setup operations, you will find that the internal setup activities will become much more effective, and you will be able to eliminate trial runs and excessive adjustments. Leave the mechanism alone and modify only the function is the slogan in the least common multiple. The least common multiple is a concept taught in arithmetic applications today. Dr. Shigeo Shingo shares in his book, A Revolution in Manufacturing, the SMED system. The name refers to the notion of providing a number of mechanisms corresponding to the least common multiple of various operating conditions. There are many examples of the least common multiple system. Success with its application depends on two fundamental principles. Establish and make settings, not adjustments. Modify the functions only. Leave the mechanisms alone. These techniques will give you a starting point to eliminate adjustments in your setup operations. But keep in mind, no adjustments will be eliminated if you do not standardize your success. Remember, eliminating adjustments could eliminate up to 50% of your time spent on setups. So be creative and innovative and find ways to make trial and error extinct. You've now looked at every aspect of your setup, from internal to external activities to standardization and beyond, but you still want to squeeze some time out of your changeover. This is where mechanization may come in handy. To mechanize is to equip with machinery. Mechanization is a last resort and should only be performed when every possible effort has been made to improve your setup times. You may be wondering, why? There are two main reasons outlined by Dr. Shingo and supported by many different experienced professionals. Mechanization will not reduce your setup time by a substantial amount. Rather, if every effort has first been made to improve the setup process, you may be able to shave another minute off of your setup time. Mechanizing will not improve the process, only a portion of the process. While it is true that mechanizing can improve a task or any activity within your changeover and may shave additional time, it is also true that if the process is poorly designed, mechanizing alone will not be able to correct the poorly designed changeover process and the operations found therein. With these two reasons in mind, mechanization is oftentimes necessary when large equipment or heavy items are part of a setup. Some practical techniques that can be used are using forklifts to move heavy items and insert tooling, tightening and loosening items, and use of moving bolsters. As you make decisions on what to mechanize and what not to mechanize, be sure that appropriate cost-to-benefit analysis is performed. Mechanization will in many cases require an investment and may not be worth the amount of improvement you will get. So, be sure that you put hard work and determination into your improvements before you mechanize. While much of the reduce methodology is focused on identifying, converting, and innovating internal and external tasks, eliminating waste is also a big part of reducing changeover times. Despite this fact, you still need to ensure that your new setup process works. Here is the key. As you test your process and make small adjustments that work, standardize those adjustments. Once the setup is locked in and repeatable, you can then begin to look at the setup from a more granular perspective. As you do this, you will find areas where seconds can be shaved and work can become easier. Be sure that anytime the process is improved, a new standard is put in place. Remember too, you have a Gemba walk, video, and a value stream map that can be left at the point of use and updated in real time. As inspiration hits, act on it and keep on improving while you reduce that setup and change over time.